The James Webb Space Telescope has once again delivered a surprise, uncovering a secret hidden in the faint light of one of the strangest objects in our galactic neighborhood. It's called the Accident, a brown dwarf that has baffled astronomers ever since it was discovered in 2020. Now, Webb's instruments have revealed that this mysterious star-like body contains a rare chemical molecule that scientists have been hunting for in the atmospheres of planets like Jupiter and Saturn for decades, but never found until now. The molecule is known as selene, a simple compound where silicon bonds with hydrogen. On paper, selene should exist in the atmospheres of gas giants. For years, scientists have expected to detect it not only on Jupiter and Saturn, but also on brown dwarfs and giant exoplanets. Yet every attempt has failed. Probes, telescopes, and detailed spectroscopic studies all came up empty. It was a cosmic puzzle. Where was the missing molecule? The answer, as it turns out, lies in the unusual history of the accident. To understand why this discovery is so astonishing, we need to step back. The accident was first spotted by a citizen scientist working with NASA's Backyard Worlds Planet 9 project using data from the retired NEOWISE mission. The object lies about 50 light-years away and is believed to be an astonishing 10 to 12 billion years old. That makes it one of the oldest brown dwarfs ever detected, nearly as old as the Milky Way galaxy itself. Its nickname, the Accident, comes from the fact that it slipped through the cracks of earlier surveys. With a mix of characteristics that didn't match any known category of brown dwarfs, astronomers nearly overlooked it. Some aspects of its atmosphere resemble very young objects, others match those that are ancient. It is both too faint and too peculiar to fit neatly into the textbooks. When researchers turned Webb's powerful infrared gaze toward the accident, they expected to find clues about why it looked so unusual. What they did not expect was to stumble upon selene. At first, the spectral signature was confusing, unlike anything the team could match to familiar molecules. Only after careful analysis did the pattern reveal itself. Unmistakable signs of SiH4, selene, the elusive compound that had defied detection for so long. So why is selene absent from Jupiter and Saturn but present here? The answer comes down to chemistry and timing. On worlds where oxygen is abundant, silicon rarely bonds with hydrogen. Instead, it eagerly combines with oxygen to form silicates, minerals that make up rocks, sand, and crystals on Earth. In hot gas giants, these silicates rise and form mineral-rich dust clouds, whipping through the atmosphere in storm-like plumes. On cooler giants, they sink deep into the interior, hidden beneath layers of water vapor and ammonia. Either way, silicon vanishes from the upper atmosphere, taking selene with it. That is why, despite decades of study, no trace of the molecule has ever been found on Jupiter, Saturn, or any other well-observed gas giant. But the accident was born in a different era of the universe. 10 billion years ago, when this brown dwarf formed, the cosmos had not yet been enriched by countless generations of stars producing oxygen. There were simply fewer oxygen atoms around. With oxygen scarce, silicon had little choice but to bond with hydrogen instead. The result, selene, preserved in detectable quantities for billions of years, waiting for an instrument like Webb to uncover it. This is more than just an oddity. As astronomer Jacqueline Faherty from the American Museum of Natural History explained, sometimes it's the extreme, unusual objects that hold the keys to understanding the ordinary ones. By studying a body as peculiar as the accident, researchers can refine their models for planetary atmospheres across the galaxy. Brown dwarfs like this one, floating freely through space without the glare of a nearby star, serve as pristine laboratories. Their chemistry plays out in isolation, offering scientists a rare chance to test theories that are otherwise muddied by complex star-planet interactions. The implications reach far beyond this single discovery. If selene can survive in the atmosphere of an ancient brown dwarf, What other molecules might be hiding in the skies of exoplanets, waiting to be revealed? As researchers prepare for the day when Webb and its successors analyze rocky, potentially habitable worlds, they know the data will not always fit neatly into existing models. Instead, they will face the same kind of surprises they see now in brown dwarfs, unexpected molecules, strange conditions, and chemistry that defies prediction. Although the accident is far too cold and faint to sustain life, it is already teaching us lessons that will matter when scientists begin interpreting the atmospheres of Earth-like planets orbiting distant stars. Each anomaly, each chemical clue, helps build a framework for understanding the diversity of worlds in the universe. And sometimes, as this discovery shows, the most puzzling objects turn out to be the most revealing. Peter Eisenhart of NASA's Jet Propulsion Laboratory summed it up best. "We wanted to see why this brown dwarf is so odd, but we weren't expecting Ceylon. The universe continues to surprise us. And that may be the greatest lesson of all. No matter how well we think we understand the cosmos, there are always hidden stories written in the light of distant worlds. Stories that only the sharpest eyes, like those of the James Webb Space Telescope, can uncover.